Try to see this. What are these kids trying to enjoy? They're trying to have their favorite orange juice. Okay. So now you also must have drank orange juice. What is the speciality or any kind of beverage, cold beverage or hot beverage? They have a similar taste. Okay. Like the first sip and the last sip, they all taste absolutely similar. Why does this happen? Because they are a solution. Okay. They are a solution, and a solution means they will be tasting similar all through. Why? Now what is a solution? We are going to talk about these things. Before that, as we discussed, that in case of any other drink, okay, you see a lemonade, so we talk about a cold beverage. On the other side we have tea, okay, which is a hot beverage. So whether be it cold or hot beverage, we see that there is a similarity, and that is known as a solution. Now we are talking so much about a solution. What is the definition of that? Let's try to define it. So a solution is a homogeneous mixture of two or more substances. Okay, so there are a few parts in this definition. Firstly, homogeneous. We will define this later. Okay, and two or more substances. So these are the two parts, and also it's a mixture, that is another thing. So there are three parts to this definition: homogeneous, mixture of two or more substances. Okay, so two or more substances, when it's a homogeneous mixture, it's known as a solution. Okay, now you may think in particular that can solution be only liquid? Okay, we are only talking about liquids in this sense, like lemonade, we talked about orange juice, we are talking about tea, but can it be something other than a liquid? So let me resolve that doubt. Yes, they can be solid and they can be gas also. Like you know the three states: solid, liquid and gas. So solid also solution, it can be called an alloy. You can see this is an alloy. And gaseous solution, it's air. So air is also actually a solution. Okay, so it can be either liquid or gas or solid. Mostly you saw it's liquid, of course, but it can be the other two states too. Okay. Now you see this alloy. Let's try to, air, we already know what is air, it's all around us. So let's try to see about alloy. Okay. So what is an alloy? How can we define it? So alloys are mixtures of two or more metals, or a metal and a non-metal, which cannot be separated into their components by physical methods. Okay, so for an alloy, try to see the definition again. Two or more metals, or a metal and a non-metal. So two non-metals can't make an alloy. There has to be two metals or more, two or more also, or a metal and a non-metal. Okay, and a very important part of it is that it cannot be separated into their components by physical methods. So maybe there are methods, there are techniques through which it can be separated, but normal physical methods, it cannot be separated. So that is all about alloys. You don't need to know much about alloys, but just the definition and what it exactly is, that is enough. Okay. Now, okay, before we proceed, we have a question. An alloy can be formed by two non-metals. So is it true or is it false? The correct answer is option B, false. We discussed that alloys can be formed by either a metal and a metal, two metals or more, two or more it can be, or a metal and a non-metal. Okay, two non-metals can't form an alloy. So you have to understand this very carefully. So now try to see. A solution has mainly two parts, a solvent, a solute, and together they give us a solution. Okay. Now here coffee is being made, right? So for coffee you are adding milk. Solvent is water, solute is coffee, sugar or cream. So why is solvent water? Because water is the main medium in which the coffee, sugar, milk, or in case of tea you are dropping tea, in case of any cold beverage you are dropping that lemon juice, so lemon. So the main base in which the thing is happening, in which the solute is being put and a solution is being made, is the solvent. Okay. Now let's try to see further. We have three types of solutions. Okay, tincture of iodine, then we have soda water, and we have air. So in these kind of three solutions, let's try to see what are the solvents and the solutes. Okay, so for tincture of iodine, we have solid iodine as the solute and alcohol as the solvent. Now, what did I mean by solvent? So, alcohol is the base, that is a solvent in which the solid is being mixed. Okay, so this is the base. Alcohol in this case is acting as the base in which the solid iodine is being put and mixed, and then a solution is being formed. Now, in the second case, water is the solvent. You have to remember, in any kind of solution we are talking about where water is present, water will mostly be the solvent, because in water we are actually mixing something. Okay, we are dissolving something. So here you are actually using carbon dioxide gas in soda water. Okay, so water is there and you are putting carbon dioxide, you are making soda water. Okay, it's as simple as that. And for another solution, we can talk about air. Okay, because in the gaseous state, we can definitely take air as the best example. So there you have various gases, but mainly nitrogen and oxygen form air. Nitrogen 78%, oxygen 21%, other gases very small quantity. You can see, so 78, 21, it's 99%. So 1% all other gases are there. Okay, so these are the different solutions, and as we discussed, they can be either solid or liquid or gas. Okay, now, okay, I didn't define one particular thing at the beginning while defining a solution. We had a small word, that is homogeneous mixture. So what does this homogeneity mean? It means it's equal. Okay, it means there is equality in all the parts. Like as we discussed at the beginning, lemon juice or orange juice or any tea, in this case coffee, whatever you are drinking, the first sip and the last sip, they always taste similar. It's not like that the first sip and the last sip, they are entirely different. And that's because there is a homogeneity, there is an equality which is ensured in all the particles. Like the small particle of a solution, they will be equal in taste, okay, to another big particle. So homogeneity in this case means equal, similarity. Okay, so it's a homogeneous mixture. A solution is a homogeneous mixture, but also you need to understand that though there is a homogeneity, but when the two particles are coming together, okay, let's consider water and lemon juice. So lemon, so water and lemon, when they are coming together, they will also hold their individual characteristics. Like lemon has an individual characteristic, water has an individual characteristic. When they both are mixed, homogeneity mixture is happening, a solution is forming, but that doesn't mean that the individual characteristic of lemon and water are not preserved. They are always preserved. Okay. Now, so another very important thing about a solution is that the particles of a solution are smaller than 1 nanometer, that is 10 to the power minus 9 meter in diameter. So you can see it's still looking big in the picture, but it's very small. It's less than 1 nanometer, that is 10 to the power minus 9 meter in diameter. So this diameter, you can see of each individual particle, the diameter, it's less than this figure which is mentioned here. So this is another very important thing. You just need to remember these features. That's it. Nothing more. Next, very important thing. You can see, before reading this or before listening to me, just see the picture once. There is a light source. Okay, a torch. It's being reflected in a solution. Now, you can see the light. Is it scattering all around? What do you think? It's not scattering all around, right? It's basically being preserved. It's in the same direction. It's not scattering. It's not scattering like this. Why? Why is it not scattering? Because of very small particle size, they do not scatter a beam of light passing through the solution. So it's very interrelated. See, in the previous feature we discussed that the particles are very small. Okay. Now, because of that reason only, they do not scatter a beam of light passing through the solution, because the particles are very small. Okay, they won't let the light, here in this case the light source, you can see it's not scattering because of the small size of the particle. Okay, so this is another very important feature of a solution. Finally, we have another feature, that is the solute cannot be separated by filtration. So filtration, you know this process, okay, the residue is being collected. Okay, I am actually the entire process is described here. You can have a solid residue at the end like this, but in this case you can't get a solid residue. So by filtration the solute can't be recovered. Okay, so we talked about many different solutes till now, but they can't be recovered in case of a solution. So filtration, I've crossed it, I'm again crossing it. Filtration in this case won't be any good. So these are all the features of a solution. Now, what did we learn in this video? We initially saw few kids enjoying orange juice, okay, and in case of any kind of beverage, hot beverage, cold beverage, orange juice, lemon juice, tea, coffee, you see there is a very similarity of taste all over the drink, right? And that is because it's a solution which is a homogeneous mixture. Okay, now homogeneous we defined later, but before that one doubt will be there in your mind, that can solution be solid or gas, or is it essential that it needs to be liquid? No, it can be solid, which is why we described alloys. Okay, alloys when two metals or two metals or more than two metals, or one metal and one non-metal, when they come together they form alloys. Okay, and on the other side air is an example to say that solution can be gaseous too. Okay, but essentially we were talking about liquid solutions. So coming back to that, we also discussed that solutions are formed by two things. Okay, solvent in which the solute gets mixed. So solute getting mixed in the solvent forming a solution. Okay, also then we define why the homogeneous term comes, because every single particle they will be equal. Okay, so which is why the tea, the first sip and the last sip, or in case of lemon juice also the same, or in case of any kind of solution, they taste the same because of the homogeneity of the mixture. But homogeneity does not mean that the individual characteristics of the solvent and the solute are not preserved. So in case of a lemon juice, let's consider the solute is lemon, the characteristic of lemon will be preserved and also the characteristic of water will be preserved, because water is the solvent, in lemon is the solute, both the characteristics will be preserved. Okay, then we finally came to the different characteristics other than that. Apart from the homogeneity of the mixture, we also discussed how light can't pass through it because the particles are very small. Also the particles are very small, that's another very important feature. It's less than 10 to the power minus 9 nanometer. That's very small. Light cannot pass, and if light won't be distracted on the other side, it will be on a straight path. Also we discussed how through filtration the solid residue can't be obtained in this case. Okay, in case of a solution you can't obtain the solid residue through filtration. So this process is actually of no use in case of a solution. So these are the takeaways from this video.